In today's lesson, we're going to learn to solve two-step inequalities. Two-step inequalities are inequalities that contain two operations. So they're going to be very similar to our two-step equations, where we had to undo the problem in the reverse order of the order of operations. So again, we're going to start with our addition and subtraction in each problem, and then we'll move to our multiplying and dividing in each problem. All right, let's take a look at our first problem up here. We have 2x plus 1 is less than 11. Okay, we're going to look at our adding and subtracting first. So we have an add 1. That means I'm going to take away 1 from each side of the inequality. Here's my 0 because those are opposites. And what's left is a 2x is less than, and 11 minus 1 is 10. Now I have a multiplication problem. To undo my multiplying, I am again going to divide on both sides. Divide by the coefficient, which is 2. And then I am going to find out that 2 divided by 2 is 1. 1x is just x. And x is less than 10 divided by 2. 10 divided by 2 is 5. So our solution is x is less than 5. And again, with the inequalities, we're going to continue to graph. So we're going to go down to the bottom where my graph is. I'm going to put my tick mark in the center and label it 5. I'm going to label the number before it, 4, and the number after it is 6. And the first thing I'm going to ask myself then is putting this 5 back in. Is 5 less than 5? Well, no, it's not. So we're going to put an open circle at our 5 to show that that is not included as one of my answers. And then I need to check both of the other ones. So let me put in this 4. 4 is less than 5. Well, that's a true statement. So we're going to shade this side of the line in to show that all of those answers, all of those numbers are solutions to this problem. Double checking, let's try the 6. Is 6 less than 5? No, it's not. So none of the answers on this side of the line could be solution sets. All right, let's look at our second problem here. We have 5x minus 7 is greater than or equal to 43. Again, we're going to start here because we are doing our addition and subtraction first. Because that's subtracting, the opposite is add, so we're going to add a 7 to both sides. Opposites, again, form a 0, and we have left 5x is greater than or equal to 50. 43 plus 7. Multiplication here. So we need to undo it by dividing. We're going to divide both sides by that coefficient of 5. 5 divided by 5 is 1. 1x is labeled just as an x. Is greater than or equal to 50 divided by 5, which is 10. So x is greater than or equal to 10. I'm going to put my 10 very center. And then I'm going to put the number before it, which is 9, and the number after, 11. I'm going to first substitute my solution 10 in here for x. Is 10 greater than or equal to 10? Well, it is equal to, so we're going to put a closed circle to show that 10 is one of our answer choices. Let's put in the number 9. Is 9 greater than or equal to 10? It's not, so we're not going to do anything on this side of the line. Then we check our 11. Is 11 greater than or equal to 10? Yes, it is, so we are going to shade this side of the line in to show that all of those numbers larger than or 10 or larger are all solutions to this problem. All right. If we look at the last problem that I have on this page, it says 7 plus x divided by 5 is greater than or equal to 11. First of all, I need to look and see this is a positive 7. And so I need to get rid of that before I can do anything here, even though there's an addition sign. I still need to get rid of this constant number first. Because that's positive, we're going to subtract the 7 from both sides. Opposites again are going to form that 0. And I have x divided by 5 greater than or equal to 4. So 11 minus 7. Now this is a division problem. To undo division, we have to multiply. So I'm going to put my parentheses on both sides. I always multiply by my coefficient, or excuse me, my denominator. So my denominator is 5. 5 divided by 5 is 1, and 1x is just x. X is greater than or equal to 4 times 5, which is 20. So I'm going to put my 20 as my first number. I'll put a 19 before it, my 21 after. And then I'm going to ask myself, starting with the 20. Is 20 greater than or equal to 20? It is, so that is a closed circle, so I know 20 is an answer choice. If I put in 19, is 19 greater than or equal to 20? It's not, so I don't do anything. Try the 21. Is 21 greater than or equal to 20? And because it is, I'm going to shade in that side of the line, showing that all of those numbers are solutions to that problem. Okay, I would like then to try a word problem here. Halfway through the bowling season, Stuart has 34 strikes. He averages 2 strikes per game. Write and solve an inequality to find how many more games it will take for Stuart to have at least 61 strikes, the league record. Okay, so first of all, we know that he is getting 2 strikes every game. So 2 times the number of strikes per game. We're just going to call that G for game. He's getting 2 strikes every game, and he already has 34. So if he has 34, whatever he's going to get has to be added to that 34. Now it says he needs to get at least 61. That tells me 61 is the lowest number he can have, but he can have more than 61. Could he have exactly 61? Yes, because he could tie that record. So we're going to say we want it to be greater than or equal to 61. And then we're going to solve it like we did up above. We're going to start with our adding and subtracting. We're going to take away a 34 from both sides. These two here are going to be my opposites. So there is 0. And I bring down my 2G is greater than or equal to 27. This is a multiplication problem now, so I'm going to undo it by dividing both sides by the coefficient. Coefficient is 2. 2 divided by 2 is 1. And 1G is still just G. We're going to keep our symbol greater than or equal to. And then 27 divided by 2 is 13.5. So that tells me that Stuart should have at least 61 strikes after 13 and a half games. Now, we don't usually call that after a half of a game, so we would probably say that Stuart needs 14 games or more to get to his 61 strikes. All right, I think I'm going to go back and do one more problem here. We didn't do any that had a negative in it, so I want to include one of those. So let's say we have negative 20 is greater than or equal to negative 2x plus 4. Okay, so first of all, again, it doesn't matter which side of the inequality we're working on. We start on the side that has the variable. So over here, I'm going to notice that I have a plus 4. To take that away, I would minus 4 on both sides. These become my 0. And I bring down my negative 2x and my is greater than, and a negative 20 take away 4 more is a negative 24. Again, I have a multiplication, so I'm going to undo it by dividing. But notice this time that when I divide, my coefficient is a negative. And the thing we need to remember when we multiply and divide by negative integers is that our inequality symbol needs to be reversed. So that's going to become a greater than. Negative 2 divided by negative 2 is 1, so just bring down the x for the 1x. Negative 24 divided by negative 2 is a positive 12, so 12 is less than x. And we'll go ahead and graph this last one also. Put my 12 in the center. We'll have an 11 before it, and we'll have a 13 after it. First thing I'm going to ask myself is about the 12. Is 12 less than 12? Well, no, it's not. So that is not included. So that is an open circle. Then I'm going to take and put my 11 in here. Is 12 less than 11? No, it's not. So I'm not going to do anything to that side of the line. Then I'm going to substitute my 13 in here. Is 12 less than 13? Yes, it is. So I'm going to shade this side of the line so that I see that all of those answers are choices. All right, so just a reminder, when you multiply or divide by a negative number, you are going to need to switch your inequality symbol to its opposite. And that's how we solve two-step inequalities.